Welcome to the webinar Digital Twin in Robotics, how to design optimal robotic application. Thank you for confirmation. But firstly, let's introduce ourselves. My name is Jacek Taczała, I'm Robot Product Manager, and here with me is
Patryk Barański, Technical Support Engineer.
So today there will be not only marketing, but there will be a lot of technical information because Patrick is the person who is using this system, is helping our customer. So there will be a lot of technical also, but how to use it and how to generate the profit for you. So together we will guide you through the fascinating world of digital twin, our innovative solution. We will show you how to design optimal application in robotics, how the system can revolutionize your production. So we are happy that you are here with us. On the last webinars, we have been talking a lot about perfect matches, like this puzzle that you see on the screen. We have been talking a lot about the integration between the PLC and the robots. So we were showing how this system can work in harmony, how create the powerful, efficient, and optimized system, just like interlocking puzzle pieces. We have been talking a lot about perfect matches between the servo and the robot. So we are showing how we can add the additional linear track for the robot, how we can put the robot on the linear track, how we can generate additional accuracy for the robot, even if the robot is on the linear track. So we are showing the synergy, how this synergy works between the servo and the robots. We also will be talking about the perfect match between the robot and the CNC. So CNC is generating some product and the robot can automate the handling, loading, and the unloading of the parts, while the CNC machine ensures accurate machining operation. So this harmony can reduce your cycle time because you have got a ready solution for our CNC controller. But Patrick, what in general we will be talking today about?
We will be talking about Gemini. It's a tool that allows us to simulate robots, machines, and whole production lines in 3D. The simulator takes us inside the working production line before it is built. And in Gemini, we can create digital twin of a production line. Jacek, what is optimal robotic application?
Yes, it's a very good question because when we are visiting our customer, sometimes they just ask us, please tell us where is the best place to put the robot. We think that it's not a good idea because for the robotization, we should involve production people from the maintenance, people from the financial department, but also the people from the sales department. Because sometimes for some of the product, the profit is very, very low. So making the robotization for the product that the profit is low is not a good idea. So the optimal application in robotics, our definition is firstly operational efficiency. What I am thinking about? I am thinking about to maximize the speed and precision to generate high productivity, but also to optimize the robot's motion path to reduce mechanical wear for the robot, so to generate the accurate path for the robot. Of course, cost efficiency to reduce energy use, to reduce resource consumption, what is very important, and of course, to design the robotics application for maximization of ROI, so return of investment. Of course, very important will be maintenance. So we would like to know what is happening with the robot. We would like to use predictive maintenance for the robots. And safety, of course, is very important. Please remember that we have got some changes in safety regulation. There will be no more actual machine regulation. There will be some new document. So safety is important. And also we would like to have the application that will be possibility to integrate it with the digital system. This is important. But Patrick, today we'll be talking about the simulation. Do you think that simulation can be the answer for this topic that I was just presenting?
Yes, but before simulation, we need to do solid analysis of requirements. We need to check every task, or every part of the production line. We assume some cycle time and precision for these tasks. And it is also worth to check environmental conditions such as occurrence of oil mist or contact with food. And let's move on to modeling. I use ready-made models and place it in the virtual world. Um, and next is simulation, and Gemini will help us in this step. We can test different work scenarios of the machine. We can choose robot path, and the point that is the most interesting for me is optimization. I change the positions of the machine, change position of production slots, and check how it affects the total performance of the production line. And for example, when a robot is integrated with CNC machine, we can add a second CNC machine and in simulation and check the performance of a whole production line again. And the last step is validation. I compared the cycle time from simulation with cycle time of a real production line. And if line meets requirements, my work is done. If not, I have another step of optimization in a simulation.
Okay, but before we will go further, you have got some bar in the top of your PC, your monitor, and there is some dedicated link where you can register on the online free of charge workshop with Patrick. I would just like to remind you, and I will do this one more time during our presentation. So, Patrick, what is really about? What can we do in MELSOFT Gemini?
In Gemini, we can reproduce our production line. So line is made of ready-made equipment from e-catalog, components such as machines, robots, conveyor systems, even manual assembly stations with workers and warehouses. So I prepared an example. You produce electric cooker. So firstly, Mitsubishi Electric robot inserts a heating plate into the frame. And then there are 6 manual assembly station and testing stations with workers. There is also a parts warehouse with manipulator, and manipulator transports parts to AGVs, and the AGVs delivers the parts to assembly lines. And these AGVs also deliver ready cookers to packing line, where Mitsubishi robots is palletizing these cookers, and then products are shipped to the customers. This is an example of a whole production line simulation from parts supply to finished product.
Okay, so you show something big. Can we do something more with the simulation?
Yes, there is also machine simulation, but firstly, let me show you a little bit more about line simulation. So we built a simulation using ready-made elements from eCatalog, machines, robots, AGVs. What is more, you can import your own 3D models and connect operating logic in Gemini to it. And building such a simulation allows us to identify bottlenecks of the processes at the early stage of this conceptual work. And to summarize, this line simulation brings our 3D models to life in the virtual space. And thanks to this, we have detailed planning and optimization. What's more, we use intuitive drag and drop interface, and the elements, for example, conveyors automatically connect. So we can build this simulation quicker. So we can make proof of concept, and by testing this machines in virtual space, we can avoid costly modifications on real machines. So we save time and money. So the more you test in a simulation, the better machine you make. Jacek, what benefits of such simulations do you see?
I see a lot of different benefits in this kind of the simulation. But first benefit that I see is measurements. So we can verify resources utilization. So we can verify how many resources we need to have to generate the application that we would like to have. We can verify the cycle times. We can verify the production pace. So this is important. What is more, analysis? So we can verify the output. So Gemini enables data analysis to support decision making. So great solution for people from the production, but also from the finance. And also improvement. This is what you said, that we can verify bottlenecks and we can change something in the application before we will start to realize it in the real life. So we can generate the costs in virtual way, so the cost will be zero. But Patrick, this what you showed, it was rather big line, very huge. So somebody could say that the Gemini is only for the huge installation. Is it true? Is Gemini only for the big system?
Of course not, because we have a second type of simulation in Gemini. It is a machine simulation, and Gemini connects to PLC and the robot simulators, and Gemini sends signals from virtual sensors to PLC and receives signals from PLC. So in this way, we can test program logic written in PLC, and we test different work scenarios, and that allows us to reduce the implementation time on a customer's side. Gemini is well integrated with PLC and robots. And the possibilities offered by machine simulation in Gemini are bringing 3D models to life, and we can also import ready models from the catalog and connect them to our PLC logic for tests. Simulation in Gemini helps us to eliminate logic errors at early stage and reduce this implementation time. Jacek, what possibilities do you see?
Yes, the possibilities and benefits that I see, some of them will be same like in the line simulation, But first benefit that I see is the integration. So the machine simulation can show us how we can just put some part of the machine to the whole the production line. We can verify what will happen when we put some element. For example, we generate the grindering machine, and we can verify what will be the bottlenecks when we will put it to our whole production line. So the next one is the same like was in the whole line, because Gemini will help with decision making. We will verify what will be the output. We can analyze what you said. It was a word that I really like, that we can verify different scenarios and choose the optimal solution. So Gemini is helping us, or simulation is helping us with decision making process for production, for finance, for sales department in the factories. And the last one is the improvement. Of course, we can improve everything in the early stage, but also when I'm thinking about the improvement, I am thinking about the future. For example, what will happen if you would like to have speed up the machine? So firstly, do the speed up on the virtual mode of your factory, of your production line, of your machine, and verify what will be the impact also in the virtual mode. We will be talking about it a little bit more. But when we will verify what is happening in the virtual mode, we can make the improvement. We can make the improvement in the virtual way, and then we will put it to the real machine. So we will avoid the costs. So improvement also in the aspect of the finance. Patrick, can we talk a little bit more about the line simulation? I know that you have prepared some examples.
Yes. We see a line simulation, and for simplicity, we'll only look at the part of it. And the first robot takes product from the input conveyor, and insert it into the first machine. And when work is finished, the robot passes it to the second robot, and it is inserted into the second machine. And then when work is finished, it is put it on output conveyor. Output conveyor transports it to the storage table. And when storage table is full, then AGVs transports these products to the second part of the line. The robots, machines, AGVs in this simulation are from e-catalog. The elements are ready made, and also operation logic used in this simulation is ready made. We don't have to write robot program, and we don't have to teach points.
Yes. So how it will be working in the machine simulation? Do you have any example?
So I will show you a machine simulation, and in this simulation, 3D model is imported and animated, and it is connected with PLC and servo controller. There is a 3-axis manipulator, and the position of axis is sent to Gemini from PLC. There is also a robot that is connected to robot simulator, and the PLC logic manages the entire process. So we can see the whole work cycle of these machines. Yeah, the PLC runs the sequence of movement.
Yes. So you showed here how the real simulator of our robots, or a real simulator of the PLC, is connected to the machine that will be building in the real life. So, but the question is, does it mean that basing on this connection between the virtual mode and the real simulator of the robot, I can measure the cycle time in the simulation?
Yes, and robot simulator calculates dynamics of the robot based on mass and inertia of the load. So we can measure cycle time there. And when it comes to a manipulator, we have acceleration time, deceleration time, and speed in servo controller. So to sum up, we can measure the cycle time of the whole machine.
Great.
Jacek, can you think of example of optimization of the large robotic line?
Yes, and I prepared some example. We have got the production of some metal part. We have got a lot of CNC machine, exactly 38. And in the past, this machine was the product was handling by the operator. And firstly, this customer decided to verify what will happen when they will put the robot, what will be the cost of the investment. But also, he would like to know what exactly and how many resources. So I'm thinking about the robot he needs to use. So he put the robots on the linear track, verify the what will happen on the production when we will put the robot on the track, how the robot will be taking the product from the CNC machine, what will be the cycle time. But what is more, he also verify how many AGV he needs to have to take the product from the CNC machine to the warehouses. So, basing on this example, it was possible to realize the verification of the production process, verify different scenarios like we were talking about. So, this kind of the simulation help with the decision making process. Patrick, can we show something simple because it was huge example? Do you have some simple example how to use Gemini?
Yes, I have a machine simulation, and there is a manipulator. It is connected to a servo controller, and position assigned to Gemini. So we can watch the movement of this manipulator and test our PLC logic. For example, we can use it to create palletizing process visualization and then send it to our client.
Yes, but the example that we are showing, it was the connection between the virtual mode of the machine and the real simulator of the PLC of the robot. But we know that sometimes we need to generate something in the fast way to check what will be having the impact of our production process. So can we simulate something without the connection with the PLC, and how to do this?
So let me show you how to do line simulation. Let's focus on one machine in this line simulation. And when I do such simulation, I care about three things: products, processes, and flow. The product is a steel cylinder, and there are three processes. And the first one is taking from input conveyor. Second one is process of machining, and the third one is putting on output conveyor. And now all I need to do is to define the product flow. And the flow is displayed as arrows between processes. And the first arrow is from taking from conveyor process to the machining process. And the second arrow is from machining process to the putting on output conveyor process. And there is a robot symbol on these arrows because the robot will transport parts between these processes. That's the robot will make the flow of the products. And now let me build an example in Gemini. I will just drag and drop two conveyors from e-catalog, um, and I will also use a feeder. A feeder is an element that creates products in a simulation. Yes, and this feeder, I can automatically connect this feeder to the beginning of the first conveyor, and there is now it's interesting moment because I add two processes. One process is process of taking from a conveyor. I add this to the first conveyor, and process of putting to conveyor. I place it onto the second conveyor. And now I add a virtual robot controller, and thanks to this, Gemini will generate a robot program. I don't have to write robot program or teach points. Yes, and now I choose Mitsubishi Electric robot arm for this application. I have just put it on the controller, and let me choose a gripper for this application. There are plenty of sample grippers in the gripper folder. I will choose a single suction cup gripper, and it automatically connects to the robot flange. Um, and and now I will go to machine folder. There are machines from different manufacturers, but I will just choose a sample machine, and then I will place it into its I will place it into the virtual world, so near the robot, so the robot can reach into the machine. Uh, and what I have to do now is to define the product flow. So I just click on the first process, taking from conveyor to the machining process, and from machining process to put on output conveyor process. Yes, and now I just start the simulation, and we can see that the robot picks part, inserts it into the machine, machining process takes place, and then robot places it on the ready part on output conveyor. Yes, so we can, of course, we can extend machining time, and I would like to say it once more. We needed only three things. So products from the feeder, and ready-made processes, and the flow.
Okay, but the question is, because you showed some ready model that you just use from the e-catalog, just take them, grab them, put to the your simulation, add to life. What if I would like to use the 3D model that was made by by me or some constructor person, and I would like to bring it to life in simulation? Is it possible?
I see that you're hungry for knowledge. I also have prepared such an example. And this is the second type of simulation in Gemini. It is a machine simulation. I'm going to import 3D model and extract two axes from this model. And the x-axis, it is a machine frame that moves along a red arrow, and the y-axis is a machine head that will move along a green arrow. So once again, let's switch from theory to practice.
Yes, so are we importing a simple 3D model with only a shape?
Yes, we import ordinary 3D model, and I choose an element that I would like to extract as an x-axis, Yes, we can see that it appeared on the left side in a project tree, new axis. And now I choose elements that I would like to extract as a y-axis. And now we have two axes in our project tree. It's that simple. And I will do the settings for x-axis. It is a transitional axis and it moves in a plus x direction. I will have to add a virtual servo controller in Gemini for this axis. Um, and now I'm going to also define the limits of this axis. It moves from 0 to 900 millimeters. Uh, and I will, in a second, I will do a similar settings from y-axis. Y-axis is also a transitional axis, but this time axis moves in plus y direction, so along the green arrow. Yes, it is a machine head. And for now, the model is live, but only in Gemini. It is not connected to our PLC yet. And I would like to add one more thing. This axis, I would also define the limits on this axis. It moves also from 0 to 900 millimeters. So we can press, we can just move this axis in Gemini and check that settings are okay. So we see that y-axis, the machine head moved to the maximum position and machine frame also moved as expected.
Okay. What about the connection with the PLC? Is it difficult to realize it to this kind of the model, or it's easy way to create it?
It is simple. I will show you how to do it. We'll use connectivity tab. There we have connectivity drivers for different manufacturers. I will choose a connection with Mitsubishi Electric PLC. And I would like to read two registers from PLC. In register D1000, I have the first axis, actual servo position, and in register D2000, I have second axis position in PLC. And what I have to do now is to pair variables from simulation. Variables from Gemini are on the left side of this table. I choose position from a virtual servo controller and I pair it with a register from that I read from PLC. So I pair the position of first axis to register D1000 and the second axis to register D2000. And now I can just press play and I will show you our PLC software for a moment. I need to just trigger the motion from our software. Yes, because it's our servo controller. We can connect a servo controller or a simulator to Gemini. And now we can see that this manipulator started to move and that is all we need when it comes to connecting to PLC.
Okay, we are talking about the PLC. What about the connection with the real simulator of the robot? Is would be the same?
Yes, it's even easier. Once again, we go to connectivity tab, and now we choose a connection with RT Toolbox. It is our software for robots, and a robot is automatically detected, and the positions are of robot axis are sent to Gemini by default. We don't need to set up anything, but if we want, we can add some signals from robot to read it in Gemini. But for now, I will just click OK and start communication. On the right side, I will move the robot with my operation panel. And in a second, we can see that the robot arm in Gemini actually moves. And that's all when it comes to robot connection.
Okay, we know that when we are programming the robot, everybody who programmed the robots, I think that 100% sure that make collision. You probably also.
Yes.
Can we check the collision in the virtual mode also?
Yes, of course we can. It's better to check collision in the virtual world than on the real, for sure. And we can do even more. I will show you. This is an example. I place Mitsubishi Electric robot arm in our virtual world, and I also place a cube. So we'll test the collisions with that cube. And now I will go to Program tab. Yes, and on the left, I have a program editor, and I will just write a simple program. Robot will go to the first point, and then robot will go to the second point. So I'm teaching the first point now, and we can see that on the left, the first line of the program appeared, and I will just drag the robot by Z plane and teach the second point. Yes, we have a sample program that has 2 lines. It is very simple. So I will just play the simulation. So the collision detection is turned off. We can see that the robot moved through the obstacle, and now now we started with collision detection turned on, and Gemini highlighted the parts that collided. Robot stopped, and I want to add one more thing. In Gemini, we have automatic path generation functions. So I can click on the second point and choose solve via path, and Gemini will generate a collision-free path for me. So now when I press play, and we can see that the robot moved and avoided the collision with this cube.
Yes, I see that there somebody put the question on our chat, and this is some kind of the reminder to you. Maybe we should told about it at the beginning. That if you have got any question, please just type it on the type with the sign question, with the question mark, and at the end we will read all of the question and we will be answering. So we kindly ask you for any question that you have. Yes, and the question for you is the way to create some custom simulation in the Gemini.
Yes, we can use Python script in this simulation. So we can import any Python library and use it. It gives a lot of possibilities. So I can create simulation made to customer specifications. And I will show you an example. I will write a script that changes the length of the cube in the virtual space. So I need you to know that we can change everything in this virtual space. So in this script, I will modify the field of the object. Object is simply a cube, and the field is the length of the cube. So I write my code in onRun function. It is executed constantly after playing the simulation, and I can just increment the length of the cube there by time. And also, when I restart the simulation, it brings the length of the cube to default value. Yes. Because when I starting simulation, we just want that everything after restart, everything should be in state 0. Yes. So in a second, we will save this script, and we play the simulation. So now we will see a cube in this virtual world, and when I play it, we see that the length of this cube increases, and when I just restart it, it brings everything back to default.
Yes, so it means that I can put some own simulation additionally to this digital twin. But when I am thinking about the Python language, I see in my head that the Python is has got a lot of different libraries for the machine learning, for the AI. Does it mean that I can use also AI in the Gemini?
Yes, because we can process data from simulation with any Python library. So we can, for example, output data to this AI library, and when this AI gives us result, we can use this feedback again in our simulation.
Okay, that's great.
Jacek, what benefits of such simulations do you see?
In this digital twin, I see a lot of different benefits, but the most important that I see is, of course, very huge e-catalog. You show the different elements that we can just take and put to the simulation. The second one is the possibility that I can verify the program that on the PLC or that will be on the robot in the real machine, and I can use it. So it's great. Of course, direct connection to the controller, it's same. And what is more, I can make the improvement because I can record the line that will be real line. We can use additional equipment, and when I will be changing something in the real machine, firstly I can change in the virtual mode, then I could put to the real machine. I can verify different scenarios. But firstly, e-catalog. E-catalog is great because we have got even 2,500 different avatars of workers, robots, conveyors, machine tools, grippers. So I can in easy way create the simple line simulation. So it's great because even if I am not the experienced person, thanks to this huge e-catalog, I can create my line in the fast way. Do you see something more?
So in practice, for example, I take gripper from eCatalog and I slightly modify it for application, and I can quickly make a proof of concept this way. Yes, I just skip the part of creating a new model in a SolidWorks. I just slightly modify these ready-made components from eCatalog.
Yes, the next element that I see is the connection between the PLC, the robot, the servo. You showed it, how it works. So the synchronization with the real PLC, I think it's something great. This is the biggest benefit that I see by using this simulation. So I can start to generate the program for the PLC very early stage. So it helped me to improve the process of preparing the whole of the machine. What about you?
So I would like to add one more thing. We can also connect HMI to the simulation. So we can test different work scenarios, not only from programmer point of view, but also from the machine operator point of view. So anybody can interact with the machine before it is built at the stage of conceptual work.
Yes, the direct connection to the robot controller. What is great that the connection is very fast. So this is great. Thanks to the connection is very fast. I can create very accurate simulation. So it is great because I can be sure that my application will be working in live.
Yes, and connection is Gemini with Gemini from simulator is 10 times faster than OPC connection, and it is important how fast Gemini refreshes the robot position. For example, when we do a collision check, I would like to check as precisely as possible.
Yes, and what we really like in Mitsubishi Electric is the ecosystem. When our customer will use the additional our solution like GX Video Viewer, this is the function that can synchronize the real machine with the real PLC. And when you will see some mistakes, bugs, so it's great that firstly you can verify the changes on the virtual mode, check what will be the impact, check different scenarios. You can even make a lot of mistakes, but the cost will be in virtual mode. So this is great. And when you will be 100% sure that everything is okay, then you can put it to the real machine. And thanks to the connection between the GX video viewer, you can verify what will be the impact on the machine, even if you are remotely. Patrick, and you as a practitioner, do you see the benefits?
Yes, from my experience, I would like to add modifications and test the next version of PLC program on simulator with Gemini before I will upload it to the PLC, and this way I can avoid downtime on customers' machines.
Yes, the next one is very huge 3D model database that I can use in the line simulation, in the machine simulation. So I can use a lot of different product that is on the market. CATIA, SolidWorks, JT, U3D, STEP, Solid Edge, SolidWorks. So the then possibilities in the aspect of the connection with the product that you are using in your factories, in your offices is huge.
Yes, I think that Gemini can import all widely known 3D models.
The next one, what is really nice, when you have got some project and you are on the very early stage and somebody is asking you to prepare the model of the line or the vision that you will be having on the line. So you can just use the simulation, you can put the ready object, and what is nice, you can in easy way create the 2D drawing line, 2D drawing. You can view it from different views. So you can generate some report, and in easy way you can make the presentation for your vision for your next project.
Yes, and it's this function to the drawing have to make documentation, and when there are a few version of simulation, each has documentation, and then it is easy to work on this on the simulations.
Statistics. I think that it's great solution. What do you think about it? Do you think that it's useful?
Yes, then there are these statistics that I showed earlier, and we see utilization of robots, machines, and HVs, and it's worth looking at this statistic. And I would add, for example, a double gripper to this robot, and I would check the statistics again. Yes, we can make modifications and quickly check how it affects the performance of whole production line.
Yes, and what is really nice, easy teaching of the robot, because I can just take the robot, grab the robot for the gripper, move to the place that I would like the robot to move, and in easy way I can generate the simulation. So it means that I don't have to be the experienced guy with generating the robotic program. I can make the simulation just taking the robot and put him to the position that I would like to have. Of course, it's very, very nice in the very early stage of simulation.
Yes, we also have a snap function, and it gives suggestions for the position of the gripper. As we can see on the right side, yes, usually it gives a few suggestions, and one of the suggestions is correct. When I personally I use it in when making simulation, I just choose the correct suggestion for me.
Yes, and what is really, really nice, even if I will just make the simple program, of course, I can make very, very sophisticated program. Thanks to the pulse processor that is in the Gemini, I can just generate the program to the RT Toolbox 3, so our solution, our software solution for the robot, and I can just upload this program to real robots, and in simulate I created the program in the simulation, but I can use it in the real robot.
Yes, and in this way, the first version of the program is usually taken from Gemini.
Yes, and what is really nice, simulation in VR, and we have what I would like to say, that we have got one of the student that is making the diploma with this software, and using this slide, I would like to say you that we have got also some dedicated version of the Gemini for the university. It is a premium version, so the premium version means that the version has got everything, but this is dedicated version for education, so you cannot use it in the industry, but you can learn everything that we are just showing you. And one of the students has made the really, really huge line, and during the presentation of his project, he used the VR, so he presented how his machine will be looking like in very, very modern way. So it was a really nice project realized by one of our students that was working with us.
Yes, and there was also a group of robot programmers that watched the digital twin of a production line in VR. And this digital twin was fed with data from existing and working production line. And programmers just want to check how the line performs, and it was in the early stage of commissioning. Jacek, what benefits of Gemini do you see?
Other benefits that I see is how we can save the money with the process simulation. Because what we can check efficiency, we can optimize workflows for shorter cycles, for example. We can check the resources used, so we can verify how many robots we need, but also how many operators we will be needed to the production line. We can, of course, realize the downtime reduction. We can save the time for generating the program for PLC and HMI, because we can start it in the very, very early stage when the machine is just, when the concept is just being realized by the constructor. So we can make easy connection between the robot programmer and the constructor person. So additional benefits is the flexibility, because I can check different scenarios. I can verify what will be the best way of the of my machine, and what it will be having the impact for our production. And what is more, you can see this on this slide. This is the element that I think that is the most powerful. So normally, when you are checking the motion, when you're checking when you are realizing motion check with the robot or the servo or other elements that is moving on the machine, you are realizing it on the on-site. Thanks to the Gemini, you can put it from the on-site to the face when the system is being designed. So you can check it here. And we have made some tests or check one of the project. It was the project with 6 robots. And thanks to the using digital twin, we reduce the building time of the machine by 6 weeks. We measure it, and we measure that it can be circa about 10k euro savings. But it's not about money, it's about the time, because thanks to this, that you shortening work time for your machine, you can realize the next project much more faster. So it means that you can be much more better than other companies that is not using this kind of the solution. So time here is, I think, much more important than finance saving. What about you?
Okay, I like that this motion check phase is started during the machine assembly time. Yes, we can, and the machine is not ready yet, but we can do this motion check and reduce the risk of when some modifications are needed. We can just before we can start the modification before it is built.
Yes, and I think that the element very important, that we can just connect all of the equipment with the real simulation. So we can connect the PLC robot. But if somebody is using some PLC that are not well known on the market, you can also use OPC server, and by the OPC server you can also make the connection of the machine. So when you have got the possibility to check all of the programs, there is great opportunity to risk reduction, that you will make some mistakes, and that you will damage some mechanical part, which we know that are the most costable. That is the big cost for it. Yes, and additionally, what I see, thanks to this kind of the simulation, it can be much more better communication between the, for example, system integrator and the end user. So they can communicate between each other. They can exchange the concept in the fast way, in this visual way, so it's very easy to change it. And what we need to say, that the technology is well known but by the end user, so the end user can tell us when the changes will be needed to create machine faster and better for them. And of course, financial benefits, because we are reducing the programming error. Eliminating this kind of the errors means cost reduction of the machine. And we know that programming errors are estimated to cost 10 to 100,000 euros. So this is the cost that we can avoid in the nice way. And what is more, the reduction of the cycle time. In MELSOFT Gemini, you can check the statistics related to the application, speed up in doing so, so we can identify the process bottlenecks, how you can verify how many robots you should be used, you can how should they be positioned, what reach should be assumed. So all of these questions can be answered by testing different project variants and verifying the results. So in our machine, from the previous point, in addition to reducing the implementation time, we also can optimize the cycle time by 37%, and we check it on some project that we were able to reduce the cycle time. So it means better productivity. It means much more bigger number of the product that we are producing.
Jacek, do you see any advantages for the end user?
For the end user, yes. The system integrator can generate the proof of concept much more faster, so he can send it to the end user. You can reduce the time of meeting. You can just communicate by the visual way. You can verify different ideas in easy way. You can change these ideas if some of them is needing. So simulation is also helping you in decision making, because you know what kind of the resources you need to use, what will be the costs, what will be the cost if you would like to generate much more bigger product. So in easy way you can verify what finance will be needed for the project. So in final, the reduction of the time that will be needed for communication, I think it's very huge benefit for the end user.
So where can I test Gemini?
Yes, you can just scan this QR code and go to our webpage. You will see some trial version possible to download it. Of course, it is possible to test the Gemini free of charge, but on this webpage you have got also some training material, so you can just verify it, and by this demo version you can test the solution. So one more time, on this webpage you can verify what is Gemini, when to use MELSOFT Gemini, and where to use it, example of use, production line. So this is what you can verify. But what is more, you can download, as I mentioned, 30-day trial period version. We will just send you the license product ID to check it.